Hello, good day. I am Charity Faith, and today I'm going to have an example on how to use Gauss-Jordan
So
elimination.
here's my example. A system of linear equations containing four variables. So first equation, w plus 2x minus y plus z is equals to 4. Second equation, negative w plus x plus 2y minus 4z is equals to 3. The third equation, 2w minus x plus 6y plus 2z is equals to 12. And the fourth equation, we have w plus x minus y plus 4z is equals to 6. So first we're going to make this into its matrix form, in which we're going to take its coefficient to it, its coefficients. So w, we have 1, 2, negative 1, z, 1, negative 1, 1, 2, negative 4. So 2, negative 1, 6, and 2. 1 again, 1, negative 1, and 4. So on the right side, we're going to write its augment. So 4, 3, 12, and 6. Now in Gauss-Jordan elimination, we're going to make a result in which its diagonal is equivalent to 1 and its non-diagonal elements is equivalent to 0. So it will look like this: 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. It will look like this. So in this augment side, we have A, B, C, and D. Now since in this row we already have 1 here, we're just going to make this, and this into 0, in which so that we can apply this column, the first column, into this one. So how are we going to do it? Now, in order to make this 0, to find the new row 2, we're going to add row 1 and row 2 to make this 0. So row 1 plus row 2. Now, for this, how are we going to make this 0? So we will just going to multiply the row 1, this, into 2, and subtract the answer to this number. So we will get 0. So the new R3 is 2R1 minus R3. Now, for this row, how are we going to do it? So we're just going to subtract row 1 to row 4 in order to find the new row 4. So R1 minus row 4. First, we're going to write this first row. Minus 1, 1. And this augment, which is 4. So for R2, R1 plus R2. So negative 1 plus 1 is equals to 0. And then here, 1 plus 2 is equals to 3. 2 plus negative 1 is 1. Negative 4 plus 1 is negative 3. And then 3 plus 4 is equals to 7. Now, to find the new row 3, here. So, 2R1 minus R3. So, 2R1. 2 times 1 is equals to 2 minus 2. 2 times 1 minus 2 is equals to negative 1. So, for the second column, 2R1. So, 2 times 2 is equals to 4 minus negative 1. 4 minus negative 1, we have 5. Now, here we have negative 1 times 2. Negative 1 times 2 is negative 2 minus positive 6. So we have negative 8. And here, 2 times 1 is equals to 2 minus 2 is equals to 0. And then in the augment area, 4 times 2 is equals to 8, minus 12, so negative 4. Now, we are on the next one, the R4, the new R4. In order to find the new R4, we only have to subtract R1 to R4. So, 1 minus 1 here is equals to 0. So, I have a mistake here. Instead of negative 1, instead of 0, I answered negative 1, in which it is R2, 2R1, 2 times 1 minus R3, which is 2, is equals to 0. So, it's not negative 1, but it's 0. Now, again, on the R4, so, on the second column, 2 minus 1, we have 1. Negative 1 minus negative 1, we have negative 1 minus negative 1, we have 0. And 1 minus 4, we have negative 3. And 4 minus 6, we have negative 2. Now, we're done with this column. Next, we're going to make the next this 3 into 1, so that it will look like this. So how are we going to do it? So the new R2, you just have to divide by itself, so that it will be equivalent to 1. So 3 divided by 3 is equals to 1. So we have R2 over 3. So we just have to copy the first row. 1, 2, negative 1, 1, and then 4. So the second row, 0 divided by 3 is still 0. 3 divided by 3 is 1, and then 1 divided by 3 is 1/3. Negative 3 divided by 3, we have negative 1. 7 divided by 3, we have 7 over 3. And we will just have to copy the next row. So 0, 5, negative 3, 0, negative 4, 0, 1, 0, negative 3, negative 2. Now, what we're going to do next is we're going to make in this column, we're going to make the rows 1, 3, and 4, this 2, 5, and 1 into 0. So, how are we going to do that? So, to find the new row 1, since we were in this in this row, so to make this 0 in the row 1, we're going to how? So make this twice, and then and then subtract it to row 1. So R1 minus 2R2, we will calculate it first if it's correct. So what is this? R1, 2 minus 2R2. So minus 2 times 1. So we have 0. So that's how we're going to make the new R1. So R1 minus 2R2. Now to find the new row 3, since we were on this row, the next diagonal is in this row, so the new row 3, so for the new row 3, to make it 0 in terms of this one, we will just have to make this multiplied by 5 and subtract it to 5 in order to make this 0. So 5R2 minus R3 is is the formula to get this 0. So 5R2 minus R3. So for the next row here, to make this 0, we will just going to again subtract R2 to R4. So the new R4 will be R2 minus R4. So the new R1, we're going to use this. So 1 minus 2 times 0 is equals to 1. So it's still 1. And then 2 minus 2 times 1, so 0. Here, negative. Negative 1 minus, so negative 1 minus 2 times 1/3. 2 times 1/3. So we have negative 5/3. And then 1 minus 2 times negative 1. So 1 minus 2 times negative 1. So we have positive 3. And then 4 minus 2 times 7/3. So we have negative 2/3. So for the R2, we were just going to copy 1, 1/3, negative 1, and 7/3. So for the new R3, 5 times R2 minus R3. So 5 times 0 minus R3, which is 0, is equals to 0. And then 5 times 1, 5 minus 5 is equals to 0. So 5 1/3, 5 times 1/3 minus negative 8. So we have 29/3. So next, 5 times negative 1. 5 times negative 1 minus R3, which is 0. We have negative 5. Next, 5 times 7/3. So 5 times 7/3 minus negative 4. 47/3. So for row 4, to find the new row 4, we have R2 minus R4. So 0 minus 0 is equals to 0. 1 minus 1 is equals to 0. 1/3. 1/3 minus 0 is equals to 1/3. And then negative 1 minus negative 3. We have positive 2. So 7/3 minus negative 2. 7/3 minus negative 2. 13/3. So we're done with the second column. So next, we're going to find the next diagonal for the third column, which is on the third row on the third column here. So how are we going to make this 29/3 into 1? So again, we were going to divide this by itself. So we have R3, the new R3 is equals to R3 divided by 29/3. So again, we will copy row 1, 0, negative 5, 3, 3, negative 2/3, and then copy row 2, 0, 1, 1/3, negative 1, 7/3. So in the row 3, so for the row 3, we're going to divide row 3 by 29 over third. So 0 divided by 29 over 3, we have 0. Again, 0 again. And then 29 over 3 divided by 29 over 3. 29 over 3 divided by 29 over 3. So we have 1. And then negative 5 divided by 29 over 3. We have negative 15 over 29. And for this, 47 over 3 divided by 29 over 3. So we have 47 over 29. So row 4, copy row 4. So next, we were going to make this negative 5 over 3 1/3 and 1/3 into 0 to make this diagonal. So how are we going to do it? So in row 1, the new row 1, in terms of this, we're going to subtract this by, multiply the row 3 to 5 over 3 and then add the answer to row 1. So we have R1 plus 5/3 R3 to make this into 0. So for R2, multiplied R3 into 1/3 and subtract. So this will become 0. I guess we'll try this. So R2 minus 1/3 R3. So for row 4, so the new row 4, again, the same process as row 2 since they are the same in this column. So R4 minus 1/3 R3. So how are we going to do this? So for R1 plus 5 R3. So R1 1 plus 5 over 3 times R3, which is 0. So still 1. So it's still 1. So we put this 1 here. And next, 0. So 0 plus 5 over 3 times R3 here is equals to 0. So it's still 0. So 0. Next, negative 5, 3. So negative 5 over 3 plus 5 over 3 times R3 here is 1. So 0. 0. And then next, R1 here, 3 plus 5 over 3 times negative 15 over 29. 62 over 29. So we have 62 over 29. So for this area, negative 2/3 plus 5 over 3 times here 47 over 29. 59 over 29. So we have 59 over 29. So in row 2, R2 minus 1/3 R3. So R2 here is 0 minus 1/3 R3, which is 0. Since it's 0, so the answer is 0. 0. Next, 1. 1 minus 1/3 R3, 0. Times 0, we have 1. So it doesn't change the diagonal form here. R2 next, 1/3 here. So 1/3, 1 over 3 minus 1 over 3 times 1, I guess. Yeah, 1 is equals to 0. So 0. Next, R2 negative 1 minus 1 over 3 times R2 negative 15 over 29, negative 24 over 29, negative 24 over 29. So in the augment area, we have 7/3 minus 1/3 times 47 over 29. 52 over 29. So we have 52 over 29. So in the R3, we were just going to copy R3. So 0, 0, 1, negative 15 over 29, and 47 over 29. So the last row, R4 minus 1/3 R3. So 0 minus 1/3 times R3, which is 0, so it's still 0, so 0. In the second column, 0 minus 1/3 times R3, which is still 0, so it's still 0 here. So here 1/3, then in the third column 1/3 minus 1/3 times 1 is 0. So it's 0 here. The next column, 2 minus 1/3 times negative 15/29, 63/29. So we have 63/29. 63/29. The next line here, augment line, so 13/3 minus 1/3 times R3 here is 47/29. So 110/29. 110/29. Now next, we were going to make this 63/29 into 1 so that we will have a result like this diagonal. So how are we going to do it? Again, we're just going to divide this by itself. So the new R4 is equals to R4 divided by 63/29 to make this 1. So let's just copy the rows 1 to 3. So 0, I mean not 0, it's 1, 0, 0, 62/29, and then 59/29, 0, 1, 0, negative 24/29, 52/29, 0, 0, 1, negative 15/29, and 47/29. So in row 4, we're going to apply this one. So in row 4, R4, 0 divided by this is equals to 0. And 0 divided by this, again, it's still 0. 0, still 0. And 63 over 29 divided by 63/29 is equals to 1. And R4 110/29, 110/29 divided by 63/29, so we have 110/63. So we have 110/63. So next, for this column, we're going to make this, and this into 0 in terms of this. So how are we going to do it? So for R1, we have to multiply this by 62 over 29 and subtract the answer to R1. So for the new R1, R1 minus 62 over 29 R4 to make this into 0. So for R2, multiplied R4 into 24 over 29 and add the answer to R1. So R1 plus 24 over 29 R4 to make this 0. So for R3, for the new R3, again, we're going to multiply R4 to 15 over 29 and add the answer to R1. I know it's wrong. Here is R2. It's my mistake. It's R2 here. So, for R3, multiplied R4 by 15 over 29 and add this to and add the answer to R3. So R3 plus 15 over 29 R4. So next we're going to do this. So for R1 here, 1 minus 62 over 29 times 0, we have, no, what happened? Multiplied by 0, we have 1. So we have 1 here. So 0 minus 62 over 29 times R4, 0, still 0. 0 minus 62 over 29 times R4, 0, still 0. And 62 over 29, 62 over 29 minus 62 over 29 times R4 here is 1, so we have 0. And for the augmented area, (59) over 29 minus 62 over 29 times R4 here is 110 over 63. So we have negative 107 over 63. So for the second row, the new row 2, R2 plus 24 over 29 R4. So here 0 plus 24 over 29 R4, times R4 is equals to 0. So still 0. 1 plus 24 over 29 R4 is equals to 0, so it's still 1. And here 0 plus 24 over 29 over R4 is 0, still 0. And negative 24, so we have negative 24 over 29 plus 24 over 29 times R4, 1, is equals to 0. So next, 52 over 29. 52 over 29 plus 24 over 29 times R4 110 over 63 is equals to 68 over 21. 68 over 21. So for R3 plus 15 over 29 times R4. So 0 plus 15 over 29 times R4 0, it's still 0. Next, again, since it's still 0 here, so it's still 0. So 1 plus 15 over 29 times 0, so it's still 1. And then here, negative 15 over 29, negative 15 over 29 plus 15 over 29 times R4, which is 1, is equals to 0. Now here, 47 over 29 plus 15 over 29 times R4 110 over 63 is equals to 53 over 21. So for the R4, we're just going to copy 110 over 63. So since we are now on our expected result of this one being diagonal and the other elements is equivalent to 0, to make this whole problem true, we will going to check this by substituting these values of the augmented area to the given equation. So checking. So for the first equation, W negative 107 over 63 plus 2 times x, which is 68 over 21, minus y, which is 53 over 21, and plus z 110 over 63 is equals to 4. So for the first equation, if they are equal, then it's true. So negative 107 over 63 plus 2 times 68 over 21 minus 53 over 21 plus 110 over 63, it's equivalent to 4. So the first equation is equal. So for the second equation, we have negative W, we have negative 107 over 63 plus x, which is 68 over 21 plus 2y, which is 53 over 21, and minus 4z, which is 110 over 63, equals to 3. So if it's equivalent, then it's correct. So we have negative 107 63 plus 68 over 21 plus 2 times 53 over 21 minus 4 times 110 over 63. So it's 3. So they are the same. So for the next equation, 2w, which is negative 107 over 63, minus x, which is 68 over 21, plus 6y, which is 53 over 21, plus 2z, which is 110 over 63, is equals to 12. So if they are the same, I hope it's the same. So we have negative 107 over 63 minus 68 over 21 plus 6 times 53 over 21 plus 2 times 110 over 63, and then this is equals to 12. So last equation, so we have W negative 107 over 63 plus X 68 over 21 minus Y 53 over 21 plus 4Z, which is 110 over 63, is equals to 6. So if they are equals, then the whole problem, the whole solution is correct. So negative 107 over 63 plus 68 over 21 minus 53 over 21 plus 4 times 110 over 63. So this is equals to 6. So since they are all equivalent, so the whole problem, the whole process is I calculated, I solved this correct. So that's how you calculate a problem using Gauss-Jordan elimination. Thank you for watching.